Alright, so this is the review for the quiz. And I'm not going to do all of these problems, but I will do some of these for you. So let's look at number 2. 2 cosine squared theta minus 1 equals negative root 3 over 2. And all of 1 through 6, all of this front page is solving for general solutions. So remember, let me do some notes over here before we start. For general solutions, this is the whole plus or minus 2 pi n thing. That's what general solutions are. So how you do this is there's 2 types that you could have for general solutions. You can either match it to a identity. So the identity choices are the sum and difference or the double angle. So if it matches, go ahead and match it up and use the simplified version of your equation. And if it doesn't match, so the second type of problem that you have is just to solve, I call it algebraically. I realize that it's not really algebraically, but this is what we were doing on the last notes, where you may have to get all the signs on one side, or you may have to factor. So let's write that. Get trig on one side, or you might have to GCF, greatest common factor, or you might have to, I don't know, take the square root. And remember, this is the one where you take the square root, you create the plus or minus answer. So that's a good one to remember. But anyways, that's going to be your first step for general solutions. So you're either going to match it, and if it doesn't match, then you're going to solve algebraically. And then after you do that first step, all your steps afterward are the same. So you kind of work to get your theta by itself. So isolate theta, or x. I mean, theta is degrees, x is radians. And you may have to take the inverse trig to do that. And lastly, you'll have to simplify as the last step. Alright, so there we go. Those are what we've been working on for the past couple of days. Alright, so keep that in mind as we're going through these, and I'm going to go ahead and pull this back over. Alright, so it looks like number 1, if you try to match this, this doesn't match with anything at all. So this is just, I call it algebra. It's not really algebra, but I mean kind of. We're going to get the trig by itself. So tangent x equals negative 1. So I just subtracted 1 from both sides. And then I'll take inverse tangent. And so from here, I can go ahead and solve. And I get pi over 4, negative pi over 4. At this point, I'll probably remind myself tangent only has that single answer, and so that's it. Negative pi over 4 plus or minus pi n. So that's a good one to get us started on. Number 2. So really, okay, what's going to be the indicator as to whether or not you match it up or not? Not that this is always or certain, but this looks super complicated. If it looks really complicated, more than likely it's going to match up somewhere. So if you look at where this matches up, always try to match it first, because if it matches, you're making it simpler for sure. So try to match it up, and it actually does match up exactly to cosine that's a double argument, 2 theta. So we've just taken that left-hand side and made it, in my opinion, much, much easier. So now we just have to do cosine inverse on both sides. So we have 2 theta equals cosine inverse negative root 3 over 2. So we can find our answers from this. So where is cosine's adjacent? Negative root 3 and hypotenuse 2. So that's here. 5 pi over 6. And then also here. At 7 pi over 6. Okay. Alright, so we've got 2 theta. Remember, these problems, this is why it's really important to show your work. Don't just think you always are done. This one is one of those instances where you actually have 2 theta equals. And so our answers right now are 5 pi over 6 plus or minus 2 pi n. And 2 theta equals 7 pi over 6 plus or minus 2 pi n. So the last step would be to divide by that 2. So our final answers, I just realized this is theta, which means degrees. Oh dear. Alright, so 5 pi over 6, that's 150. And this is 360. This is 210. And that's 360. Alright. So theta equals 150 divided by 2 is 75. Plus or minus 180 in. And 210 divided by 2 is 105. Plus or minus 180 in. If you're curious, just so you know the division, how that would have worked, that would have been 5 pi over 12 after you divided by 2, and that would have been 7 pi over 12. So, just a good thing to note, but theta is degrees, so I should have done that in degrees. All right, number 3. 4 sine squared x equals 1. So, this looks pretty complicated, but even though it looks complicated, unfortunately it doesn't match up to anything. So since it doesn't match up, this is an algebra problem. So our first step with algebra problems is try to get the trig by itself. So I'll divide by 4. So I get sine squared x equals 1/4. And then I'll take the square root. So this is one of those that we are going to take a square root or create a square root. Therefore, I am creating this plus and minus here. When this red is something I made a square root. If you make a square root, you have to include the positive and the negative answer. It's really important that you do that. So now we get sine x equals plus or minus. So the square root of 1 is 1. And the square root of 4 is 2. Alright, so this is that case where I'm actually going to branch this off into 2 answers. The positive ratio and, let me do that in a different color, the negative ratio. So let's do the positive ratio first. Sine x equals half. So x equals sine inverse of half. Alright, let's go ahead and finish that off. So that's 1/2. Let's check radians. Pi over 6. And then 1/2. 5 pi over 6. So far I've got 2 answers going on. Let's check out sine x equals negative 1/2. So x equals sine inverse of negative 1/2. So that's negative pi over 6. And 7 pi over 6. All right, so let's go on. Let's get the answers, the final answers. I'm going to put right here. So just to check really quickly, I do already have x solved for, so I can just go ahead and start with my answers. It's different than this problem up here because your variable wasn't solved for. You still had to divide by 2. But here, x is already all by itself, so I can go ahead and start with my final answers. And I'm just going to rank these down. So it's pi over 6, 5 pi over 6, negative pi over 6, and 7 pi over 6. So let's do that. So I got pi over 6 plus or minus 2 pi n. I've got 5 pi over 6 plus or minus 2 pi n. I've got negative pi over 6 plus or minus 2 pi n, and 7 pi over 6 plus or minus 2 pi n. And that's it. Alright, so I'm going to leave y'all with the last 3 problems. If you want to come back to this, you can. But number 4 would be a matching problem. So I'll just tell you how to start it. Number 5 is another matching problem. And then number 6 would just be an algebra problem where you're going to get the variable by itself. So that's how you would start off 1 through 6. Let's go on to the next page. Alright, so number 7 is a problem that we've done. We're going to find the exact values for these things. So our first step on these problems was to, within the correct quadrant, so this tells me what quadrant, you're going to put in your problem. So 3 pi over 2 to 2 pi is in quadrant 4, and I want the hypotenuse to be 7 and the adjacent 6. So that's a squared plus b squared equals c squared, so that's 49 and 36. Subtracted makes 13. Checking that it's negative. It is indeed negative because it's down. Alright, so one at a time, let's do sine of 2x. So my identity says sine of 2x is equal to 2 sine x. Cosine x is equal to 2 over 1. Negative root 13 over 7, and 6 over 7. So that's negative 12 root 13 over 49. Alright, cosine of 2x is equal to cosine squared minus sine squared is equal to 6 over 7 minus negative root 13 over 7. 36 over 49 minus 13 over 49 is 23. Now this is the type of problem that you want to go ahead and use tangent as the ratio sine over cosine, because I'm just going to insert this answer in for sine 2x and insert this answer in for cosine of 2x. So my top is negative 12 root 13 over 49 all over 26 over 49. So I get negative 12 root 13 all over 26. Ooh, and unfortunately this does simplify one more time, 2 and 2, so that's 6 and 13. Negative 6 root 13 over 13. Alright, 8 through 11. These are some just rewriting. So let's do number 9. Write cosine of 14x in terms of sine of 7x and cosine of 7x. So let's start with, you got to start with your starting place. Cosine of 14x. Well, that's equal to cosine double 7x. Well, your double cosines had options, so this is what tells you which option to use. You want to use sine and cosine. So that's where we say, well, that's cosine squared minus sine squared. And what you insert right here is always right there. That's why it says 7x and 7x. So that's going to be cosine squared 7x minus sine squared 7x. And that's it. All right, let's go on to page 3. All right, so some proofs. I believe we've done a lot of these in class. So I'm not sure where to start, really. Number 13 doesn't particularly look fun, so let's do 13. Oh, it's actually not that bad. I don't think. Let's see. So I definitely think this is the side to start with. And the first thing that I notice is 1 plus tan squared is an identity. And that identity is that it's secant squared. And so then keeping this top as 2 tan x. Well, it's not really looking very much like this right now. Let's remind ourselves really quickly what sine of 2x is. So that's 2 sine times cosine. So I'd like to see separate trigs here. So let's rewrite this as 4 separate trigs. So I've got 2, I've got tangent, and I've got secant squared. So 2 is just 2 over 1. Tangent is tangent over 1. Now secant, but it's secant in the denominator. So you got to make sure you indicate it's in the denominator by saying 1 over secant and another 1 over secant. So let's relate it back to sines and cosines. So tangent is sine over cosine. And then 1 over secant is cosine and another 1 over secant. And so we end up with 2 sine cosine. That's a times, sorry, I'm writing fast. 2 sine x times cosine x, which is sine of 2x. All right, number 14. This is actually a lot simpler than it looks, because if you take this whole sine and you match it up to an identity, this matches to sine of a plus b. So we're going to take sine of 3x over 7. That's your a, and add 4x over 7, which is the same thing as sine of 7x over 7, which is sine of x. Alright, and I think I'm going to be done because the rest of these we've done in class together. All 3 of these were on 5.8's homework, so you can go back and look at those.